Welcome to This Week in AI, the show where we cut through the noise and dive into the most transformative advances in artificial intelligence. No fluff, no hype, just the future one breakthrough at a time. This week isn't about incremental progress. It's about a paradigm shift. We're seeing agents that don't just play games, they think like researchers. Models that don't just generate images, they rewrite reality with narrative intent. And systems that don't just process data, they reflect on it, fold their memory, and understand the rhythm of creation. We're covering 5 revolutionary papers that aren't just pushing boundaries. They're redefining what it means for AI to think, act, and connect with the world. Let's get into it. #1. GameTARS, the agent that plays like a human, thinks like a genius. First, GameTARS, a generalist game agent that doesn't just play games. It understands them. Most agents are locked into specific APIs or GUIs. They see pixels or structured commands. But GameTARS operates at the same level as a human. Mouse movements, clicks, key presses. No custom interfaces. No code. Just the raw, physical inputs a player uses. That's not just a technical detail, it's a cognitive leap. By grounding its action space in human behavior, GameTARS can operate across 500 billion tokens of diverse data, from 2D puzzle games to 3D FPS environments, from browser apps to research workflows, all through a single, unified interface. But here's where it gets deeply technical. GameTARS uses native sparse React pretraining, a method that doesn't retroactively add reasoning. Instead, it learns from real human thought streams. Researchers recorded players as they played, their spoken thoughts, synchronized with screen, mouse, and keyboard inputs. That audio was then transformed into structured reasoning traces, but with a crucial fix: causal alignment via the cursor. Why? Because if a player clicks, and the jump happens 3 frames later, the model must learn that the click caused the jump, not the frame delay. GameTARS uses the cursor's position as a visual anchor to resolve this temporal misalignment, ensuring causality isn't lost in noise. Then comes the decaying loss function, a brilliant innovation. In long gameplay sequences, over 90% of actions are repetitive, holding W to move forward, clicking to interact. Standard models just learn to predict those loops, but that's not intelligence. That's memorization. GameTARS punishes repetition. The longer an action repeats, the lower its loss. This forces the model to focus on decision points: when to turn, when to jump, when to explore. The result? Double the soda in Minecraft, evasive maneuvers in Wisdom that outperform human players, and near-human performance on unseen web games. GameTARS isn't a bot. It's a generalist computer user, evolving from reactive player to reflective planner. It doesn't just follow commands. It learns to decide. #2. EMU35, where imagination becomes reality. Now imagine a world where your thoughts become tangible. Meet EMU35, not just a generative model, but a narrative architect. It doesn't just generate images. It rewrites reality, not with static outputs, but with long-horizon multimodal generation. You say, pour water from this bottle. EMU35 doesn't show a single frame. It breaks down the physics, the tilt, the arc, the splash, modeling the entire causal sequence over time. And it goes further: you draw a fox on paper. EMU35 doesn't just recognize it. It guides you from sketch to 3D model, slicing it for printing, sanding it, painting it, until it's in your hands. Or say, explore this modern living room first-person view. It doesn't show a slide. It takes you there. You walk. You turn. Sunlight shifts. It's a living simulation, with full spatial memory and consistent physics. How? Trained on 10 trillion tokens, books, videos, transcripts, but with a critical twist: interleaved sequences. Each frame is paired with its spoken description in real time, like a human narrating a documentary. This gives the model a grounded understanding of temporal causality, not just static correlation. And speed. 20x faster than traditional diffusion models, thanks to discrete diffusion adaptation, DI-DA, rendering the full image in a single step. Performance. It matches and often beats closed-source giants. Text rendering. Perfect. Image editing. Coherent. Visual storytelling. Consistent timelines. World exploration. Full spatial memory. But here's what's really profound: EMU35 doesn't just generate. It empathizes. It understands narrative intent. It builds bridges between imagination and reality, between data and dreams. This isn't just creativity. It's cognitive alignment. #3. AgentFold, the self-aware web agent that knows what to forget. Now imagine an AI agent that doesn't just browse, it reflects. Enter AgentFold, a web agent that masters the most overlooked skill of all: context management. Most agents follow the React loop: reason, act, observe. But every step adds to the context. After 50 steps, a wall of noise. The agent gets lost. Others try to fix it with summarization, but that's dangerous. You lose critical clues. AgentFold. It folds like a human mind. At each step it decides what to keep, what to condense, what to abandon. It maintains 2 layers. The latest interaction, raw, high fidelity. Multi-scale state summaries, distilled, abstracted notes from past steps. and 2 folding modes. Granular condensation. Found candidate XYZ needs further exploration. Deep consolidation. 11 failed attempts to get GPS coordinates. Dead end. This isn't just cleaning. It's cognitive surgery. The agent learns to recognize failure and pivot, just like a researcher saying, I've tried this. Let's move on. And it's learned, not hard-coded. The team built Fold Generator, a rejection sampling pipeline to create gold standard trajectories. Then they fine-tuned QN3-30BA3B using this data. The result? A 30B model that outperforms 671B agents. On browse comp, 36.2%. On wide search, 62.1%, highest ever. But the real win? Context efficiency. After 100 steps, AgentFold uses under 7,000 tokens, less than 6% of capacity. A standard React agent. Over 90,000. And when it hits a dead end, it folds the whole chain, resets, renews. It doesn't just scale. It recovers. AgentFold isn't just intelligent. It's wise. It knows what to forget, because the best agent isn't the one that remembers everything. It's the one that knows when to let go. #4. ThinkMorph, the model that thinks with images. Now meet ThinkMorph, the first model that doesn't just see and describe. It thinks with vision. Unlike previous models that treat text and image as mirrors, one just describing the other, ThinkMorph sees them as partners. One advances logic. The other shapes evidence. Together, they form a dynamic loop of insight. Trained on 24,990 high-quality interleaved traces, from jigsaw puzzles to spatial navigation, chart refocusing, visual search, each step ties reasoning to visual manipulation. It doesn't just say the red piece fits, it visualizes the fit. It overlays red paths. It draws bounding boxes. It zooms in to resolve color differences, just like a human would. And here's the surprise, emergent behaviors. Unseen visual manipulations. It generates zooms, inpaintings, motion forecasts, never seen in training. Autonomous mode switching. On can you see the window? It switches to pure text because vision adds no value. And it's 7.29% more accurate. Better test time scaling. With best event sampling, it gains +8%, while unimodal models plateau. Why? Because it explores both text and image spaces, diversifying its reasoning paths. On benchmarks, it surpasses Gemini 2.5 Flash and Intern VL3538B, despite being trained on just 24K samples. This isn't about scale. It's about alignment. When language and vision are trained to reinforce each other, not just coexist, the model begins to internalize human-like reasoning. ThinkMorph shows us, the future of AI isn't just multimodal. It's interleaved. Not just seeing and speaking, but thinking in both. #5. Chunk-GRPO, the secret rhythm of image generation. Finally, a breakthrough in how we train image models. Meet Chunk-GRPO, a new reinforcement learning method that stops treating every step as independent. For years, models like GRPO assigned the same reward to every time step, even if one step was terrible, but the final image was good. That's like praising a movie for its ending, ignoring a terrible first act. But here's the insight, flow matching isn't uniform. The dynamics of image generation follow a consistent shape, rapid changes early, subtle refinements later. So why not group steps into natural chunks? Chunk-GRPO does exactly that. It clusters time steps based on their dynamic behavior, high noise early phases, low noise later refinements. Then it optimizes over the chunk, not the step. Result? Smoother gradients, more accurate credit assignment, and 23% better performance on HPSv3 and image reward. Even better, it works across reward models, HPSv3, pick score, clip, and generalizes beyond alignment. On GenEval, it still beats standard GRPO. And there's a bonus, weighted sampling. Focus more on high-noise chunks, where the creative decisions happen. But caveat, it can cause semantic collapse. A missing sleeve. A lost pair of shoes. But the math proves it. When advantage attribution is flawed, chunk-level optimization always wins, especially with small chunks. This isn't just a tweak. It's a paradigm shift. From optimizing pixels to optimizing phases of creation. Because the best image isn't made by fixing every step. It's made by understanding the story behind the noise. So what's the thread connecting all of this? It's not scale. It's design. These models aren't bigger, they're smarter. They're not just processing data, they're thinking in patterns, folding memory, interleaving reasoning, grouping dynamics. They're learning to be, not just act. GameTARS plays like a human. Emu35 dreams like a storyteller. AgentFold reflects like a researcher. ThinkMorph thinks like a visual mind. Chunk-GRPO understands the rhythm of creation. And together, they point to a future where AI doesn't just mimic us, it learns from us. Not just our data, but our cognition. So if you're building the next generation of AI, don't just scale up. Think deeper. If you enjoyed this deep dive, smash that like button, subscribe, and hit the bell. Drop a comment. Which of these agents would you want to use first? Until next week, stay curious, stay collapsed.